We are going to see some problems related to standard deviation, the intention of doing problems in economics. This is the first problem that we have for the day today. Summation of x1 squared divided by n. This is quite interesting method. There are different methods in which you can find out the standard deviation. Please do not hurry up. Please do not rush up in terms of solving the problem. Good morning and welcome to the third session on measures of dispersion, chapter 6 in economics. From the last chapter, we have been seeing some interesting problems which have been adding a great value to economics. In this session also, we are going to see some problems related to standard deviation and how we are going to solve it using the different methods altogether. So let's have a quick look into the topics for today. These are the topics: the standard deviation problem, direct method, we have the solutions for it, the assumed mean method with the solution, the step deviation method with the solution, and not to forget the Lorenz curve. That's a very, very important topic that we are going to address in terms of statistics. So let's go forward and try to understand the problems. As I've told you in the previous session also, the intention of doing problems in economics in the first PUC part is to score more marks. So please do not get deterred, or please do not move back and feel that complacent saying that why should I do statistical problems. The need for doing statistical problem helps you in both ways. One, it will help you to understand the concept. Two, it will help you to score better marks. So let's go forward, try to understand the problem and solve it in the best manner possible so that you are able to score the best marks. Let's move going forward here. This is the first problem that we have for the day today. What is the standard deviation problem that has been given? The number of televisions sold in each day of a week. So we are going to take a retail showroom which is going to sell some television sets, and these are the values that we are going to see: 13, 8, 4, 9, 7, 12 and 10. So you are able to see that there are some values that are being displayed on the board. You have to find out the standard deviation. So how are we going to find out the standard deviation? Quite simple. This is the first value that has been given. Write down the values that are being given on the problem under the column X1. So these are the selling rates, the selling units that are being found on the first week. So that is 13, 8, 4, 9, 7, 12 and 10. Immediately do the square of the values that are being given. So 13 square, 169. 8 squared, 64, 4 squared, 16, 9 squared, 81, 7 squared, 49, 12 squared, 144, 10 squared, 100. So you will get now two summation of x1. When you add all the values in that column, you will get the total as 63. Now summation of x1 squared column, you will get it as 63. Now if you look here, it is quite important here that the values that we are trying to understand is just very, very close. So you are just going to put in the formula, that is summation of x1 squared divided by n minus summation of xi the whole power squared divided by n. So when you calculate this value all together, you will be able to understand the value here is 623, the total value. I just forgot to mention you here, it is 623. That is what we have got. So 623 divided by 7, and here it will be 63 by 7 whole square. So when you find it out, the value will be 89 minus 81 square root. Not to forget, in standard deviation, it is always the square root that we have to keep. Hence, the standard deviation value, that is the square root of 8, is equal to 2.83. So very, very simple. You will be able to get the answer in a minute. Let's try to understand the problem. Let us go a quick recap on the problem. X1 is the column where you're going to write down the given set of data. The next column will be x1 squared. So that will be the squared values of each of the data that has been given. Do the total of the first column, that leads you to the value 63. Do the total of the second column, that leads to the value 623. So now what you do here is that you will put it in the formula here. 623 divided by 7 minus 63 divided by 7 whole square. You will get a square root of 8, and the square root of 8 value is 2.83. So that is the standard deviation that you have found out for today. Quite simple. Let's move forward, and now we are going to use the assumed mean method. Assumed mean method, please keep it in your mind. This is quite interesting method, and it also involves a little bit of calculation. Why? Because here we are going to assume the mean. We are going to keep a number in the mind and then take it forward. So that is why assumed mean method is a very important method. So now let's try to understand the marks scored by 10 students in the test is given. Some numbers 25, 29, 30, 33, and then it moves to 37, 38, 40, 44 and 48. Now we are going to find the standard deviation but using the assumed mean method. So how to do this problem? Here you have x1, that is the data that is being given here, the student scores that are being given, 10 scores are there. You are going to assume a mean value here. What is the assumed mean here that you are going to take is what is going to matter. So the assumed mean value is 35. So that is the center point here. So 25 minus 35 minus 10 minus 6 minus 5 minus 2. Assumed mean, I'm going to write it here, that is going to be 35. That is the value that we have taken here. So subtracting x1 values from that, you will be able to get this values. So everywhere you will be able to get the values subtracting that x1 from 35. So what's the total value that you are getting here? The total value is 9. Now let's try to see the value. We are just going to square up the deviation values. So 10 square, it's going to be 100. Before I do the squaring, I'm also going to tell you a very important but yet a very simple thing also. Many times students get confused. Sir, this is minus 10. So if I do minus 10 square, will it be minus 100? Absolutely not. Minus into minus is plus. So whatever you do as a square, the value will be positive only. So minus 10 means it is plus 100. The square value will be in positive. So minus 6, 36, minus 5, it is 25, minus 2 is 4. Automatically you will be able to get the square value. Get the total of this column. The total of this column is 453. So that's the value what you are going to see here. The total value here is 453. Now you're going to just put it in the formula altogether. The formula is almost the same formula. We are not going to change the formula here. So what we are going to do is summation of di squared divided by n. That is 453 divided by 7, because 7 observation is what we are interested to look into. And then you would also see the values coming up here. And just put up the value, you will be able to see the factors coming up. Why we are taking 7 main observations? Because these 7 factors, if you look into it, those are the key factors, key observations here. Moment you start finding out the standard deviation value, you will get the answer as 6.67. Now, the step deviation method, that's the next method that we are going to see in terms of standard deviation. Now, let us look into the problem. Amount that the children have spent for purchasing some eatables in a one-day trip are 5, 10, 15, 25, 30, 35 and 40. So that's what you're going to see. Using a step deviation method, we are now going to find out the standard deviation. Now let me just remind you, there are different methods in which you can find out the standard deviation. You can use a direct method, you can use an assumed mean method, you can also use a step deviation method. So this is where you are using the step deviation method to find out the answer. So what is going to be the answer here? This is what is going to look. Now let's look into the column there. You have the factors there taken here at the first column: 5, 10, 15, 20, 25, 30, 35, 40. Then you need to take an assumed mean here. The assumed mean here is 20. So A is equal to 20. Step deviation method. You will be able to get the difference value. Now, you have to use the common factor here in order to get a step deviation. The common factor is 5. If you look here, from every value, there has been a movement of 5. units. So 5 to 10, 10 to 15, 15 to 20, it's a jump of 5 numbers. So automatically, when you take this value, the x value minus the assumed value divided by 5, you will get this column. Do the summation of it. The summation value is 4. Now, let's do the square of this. So 9, 4, 1, 0, 4, 7 and 16. The total value is 44 here. So let's try solving the values here very clearly. It is the same formula here, 44 divided by 8 all in square root minus 4 by 8 whole squared into 5. So that is summation di squared by n whole squared into c. If you solve this value, you will be getting the standard deviation value as 11.45. Very, very simple, very interesting, though the steps might look little bit tedious or might be on the higher side, but then it is very, very easy for you to solve it. No need to worry at all. All you have to put down the values first, then you need to start solving this value, then you have to get the common difference factor, square up those values, get the total, put it into the formula, and then you will be able to see what is the standard deviation altogether. All you have to keep in your mind is the number of observations, how are you getting the square values, and then you substitute it here. Now, the most important thing that I would like to say when you are trying to solve a statistical problem is that you might go wrong in either adding up because you are too quick in using your calculator, or you might have forgotten to add a number, or you might have forgotten to do a squaring. So please take time. You take your time, you find out the square value, do it step by step, you will be able to get the formula. And whenever you are using the whole square root, first solve the internal numbers and then take the whole square root. Please do not hurry up, please do not rush up in terms of solving the problem. Our intention is not to complete the paper at the first. Our intention is to get the highest marks possible. So when you want to score marks in statistics, you have to go step by step, slowly, patiently, so that you are able to score some marks. So what you need to do, look into the columns, look into the tabular columns clearly, find out where you have mentioned the variables, find out the exact difference, total it up carefully, do the squaring carefully, and then start substituting the values in the formula. Definitely you will be able to get the correct answer and also the correct marks altogether. So that is why it is very, very important that you pay attention, a little bit of attention here, and you will be able to score the maximum marks in economics. Moving forward, we are going to talk about a very new and an interesting topic called as the Lorenz curve. Now, what is this Lorenz curve all about? It's a measure of dispersion discussed as far as only on the numerical value. Now, a graphical measure of Lorenz curve is available for estimating the inequalities. Now, many times you will see that whenever we talk about economic data, there are factors, there are times that you will get statements like this: the top 10% of the people earn more than 50%. Top 20% of the people have 80% of a country's wealth. How is those statements coming up, and what is the meaning of those statements when we try to understand? That means when you're going to draw a graph and you're going to understand, there are some people who are at the extreme ends, who are at the extreme values, who are trying to score the maximum when compared to the minimum factor. So Lorenz curve will give you an information expressed in cumulative manner to indicate the inequality. So you will see that when you draw up a graph like this cumulatively, you will see that there are certain values at the peak which will give up the total in comparison to the data that has been given. So for a country like India, when they make a statement saying that 20% of the Indian population holds 80% of India's wealth, that means the Lorenz curve will give out the inequality saying that 20 people holding the share of 80 people. So that's a very big value, and you will be able to understand it graphically, trying to understand the inequalities in the long run. So this is a very, very informative and an interesting tool altogether, which helps us to understand the degrees of inequality. inequalities. And it is also used to understand different parameters, like for example, if you're going to understand the percentile scoring, if you're going to understand the comparative analysis of GDP, comparative analysis of defense, or any other sectors altogether, Lorenz curve is a very, very important and an informative tool that you can rely upon. Using this curve, using this graphical tool, you will be able to understand the comparative analysis even between different nations altogether. So moving forward, the conclusion part for today's session is recapping ourselves in terms of understanding the entire measures of dispersion. So we started with a very, very simple formula and format called as the range, which is the simplest format used in statistics, which is used to calculate the difference between the largest minus the smallest. So that is how we were able to calculate the range of the data that is available in a given set. So that's a very, very interesting and a helpful topic altogether, and it was even quite easy for us to score in that pattern. Now, the quartile deviation, which we started learning after the range, it's not affected by extreme values. It's only based on the 50% of the data. Why? That's where we were trying to understand. Quartile deviation, when we are taking in steps of 4, that value is very, very important. Steps of 4. Then we understand that the mid-range values are not affected. Only the extreme range values are affected. The 25% to your left, the 25% to your right are the ones which are affected. So using the quartile deviation, we can find out what is the deviation from the average. So even that particular statistical tool was very interesting for us to understand and also solve it as a problem. Now, it is more difficult to understand the mean deviation when I use the word MD and SD, mean deviation and standard deviation. Both of them are based on different values from their average. So mean deviation and standard deviations are not going to be the similar kind of thing. Yes, we have a variation, we have a factor coming up. So we need to understand it in here, because mean deviation is calculated as an average of deviations from the average, but standard deviation is from a different factor altogether. There might be some times that, it ignores the signs of deviation, because if you look into the mean deviation, sometime you might not be able to get an exact or an accurate value. That is because it tries to deviate against the numerical values. It might sometimes ignore those smaller values. So that's why you might find it as an unmatchable or unmathematical in nature. You might just find that mean deviation is just a one stand answer. It is not able to give you an equivalent or an exact answer every time. In order to solve that problem, we move into standard deviation, which attempts to calculate. I'm again using the word attempts to calculate, because like the mean deviation, standard deviation tries to come as close as possible. Now, I want to say you this, when we talk about statistics, we are not 100% accurate, but we try to make a progress, we try to take a step to move towards that 100%. So that is why standard deviation will also try to make an attempt to move to calculate the average deviation from the mean. Like the mean deviation, it is based on all values and it's applied more in advanced statistical problem. That is what is being widely used. As I was telling you in the chapters in the previous session, standard deviation is the most appropriate statistical tool, because that gives you an exact or almost equal to exact. Where is a process, where is a data that is varying from the given set of standards, from a given set of specifications altogether. So when you go to industries, when you go to a national level application used by the large institutions, always standard deviation will be the most preferred statistical tool in comparison to mean deviation or any other tool. With this, we come to the conclusion for today's session. I hope and believe this chapter, Measures of Dispersion, was very, very interesting, informative and educative altogether. The usage of this chapter lies in understanding the problems applying the formulas and trying to get the correct answers. So when you are trying to apply the statistical formulas, the statistical methods, please keep in mind all those small values, all those important steps, so that you will be able to get the best marks in the exam. Having said so, I believe that all the information that you have gathered from this chapter will definitely come to use in terms of your exam, also the concepts in life. Thank you once again for joining me on this wonderful session. Have a great day.